There is a light that has touched everything you have ever loved. It fell across your face this morning before you were fully awake. It warmed the side of a building you walked past without thinking. It is, at this very moment, sitting somewhere above your horizon, or just beneath it, depending on where you are and what hour it has become, doing the one thing it has done without fail for 4.5 billion years. It is shining. And because it has always shined, because it rose today and yesterday, and on every single morning of your entire life, you have quietly stopped noticing it. You have folded it into the background of the world, the way you stop hearing a clock once you have lived with it long enough. Tonight, I want you to notice it again. Slowly, without fear. From the safety of wherever you are lying right now, warm and still and far away from any harm. Because the thing in the sky that you have taken for granted is not gentle. It is not calm. It is not the soft yellow circle a child draws in the corner of a page. It is a controlled detonation the size of 1,000,000 Earths, a churning sphere of plasma so violent that if you could somehow stand upon its surface for the length of a single heartbeat, you would not so much die as cease to have ever meaningfully existed. And it is held together, balanced on the finest possible edge between collapse and explosion, by forces that have been running quietly and patiently for longer than the ground beneath your home has been solid. For almost all of those billions of years, it has been kind to us. It has been the reason there is a here at all. Every breath you have ever taken, every meal that has ever kept you alive, every warm afternoon you have ever drifted off into, traces back along an unbroken thread to that one source of light. We owe it everything. We are, in the most literal sense, made of its leftovers and warmed by its patience. But a thing that gives you everything can also take everything. And the same star that has cradled this planet through the long, slow miracle of life has, more than once, leaned a little too close. It has reached out across 93 million miles of empty space and brushed our world with the edge of its temper, and each time it has done so, it has left us a quiet warning, a note slipped under the door, telling us in language we are only just beginning to read that the peace we live in is not permanent, and was never promised. So tonight we are going to talk about the sun. Not the friendly one, the real one. We are going to walk all the way down into its burning heart, and then all the way out to the day, far in the future, when it finally lets go of this world for good. We are going to look at the nights it has nearly ended us already, and the night it still could, the one that might begin while most of the planet is asleep, the way you are about to be. None of this can touch you here. You are safe, and you will stay safe, and nothing in this story is happening to you tonight. It is simply a way to understand the enormous, beautiful, indifferent thing that hangs over all of us, so that when you close your eyes, you close them with a little more wonder than you woke up with. If these long, quiet journeys help carry you into sleep, you can follow along and subscribe, and they will keep finding you on the nights you need them. That is all. There is nothing else to do now but breathe, and settle, and listen. Let us begin where everything begins, with the star itself. Part 1. The star that owns you. Picture the distance for a moment, even though it is a distance the human mind was never built to hold. 93 million miles, roughly 150 million kilometers of nothing at all, of cold and dark and emptiness, between you and the furnace that keeps you alive. It is a gap so vast that the fastest thing in the universe, light itself, travelling at a speed that would carry it around the entire Earth 7 times in a single second, still needs more than 8 full minutes to cross it. Sit with that. The sunlight resting on your windowsill tonight, the last of it if the sun has set where you are, or the memory of it if the day is already gone, left the surface of the star more than 8 minutes before it reached you. You have never once seen the sun as it is. You have only ever seen the sun as it was, 8 minutes and 20 seconds into the past. If the sun were, in some impossible instant, to simply blink out of existence, you would feel nothing for those 8 minutes. the sky would stay bright, the afternoon would carry on, and then, with no warning at all, the light would end, and the warmth would begin its long fade, and only then would the planet understand that its star was already gone. That is the strange truth of living beside a sun. Everything we know about it arrives late, and everything we love about it comes to us across a distance we can barely imagine. And yet, despite that distance, despite all that empty space, the sun is not a small thing in our world. It is the only thing. We tend to think of the solar system as a collection. The sun and the planets and the moons and the comets and the drifting rubble, all of it sharing the stage. That picture is gently, completely wrong. If you were to gather up everything in the solar system, every planet, every moon, every asteroid and comet and grain of dust, all of Jupiter with its monstrous bulk, all of Saturn and its rings, the Earth and everything that has ever lived on it, and you weighed all of it together, you would find that this entire collection accounts for barely 2 parts in 1,000 of the total. The sun is everything else. The sun is more than 99.5% of all the matter in the solar system. The planets, our whole world included, are little more than the crumbs that did not quite fall into the fire when the system formed. You could fit more than 1 million Earths inside it, not stacked end to end, but poured in, filling the volume, and even then there would be room to spare. We are not the sun's companion. We are not its partner. We are a fleck of dust caught in its gravity, held in a wide, slow circle by a pull so absolute that we have never once, in the entire history of the planet, threatened to escape it. Everything you have ever done, every place you have ever travelled, every person you have ever met, has happened inside the grip of that single object, on a small wet stone falling endlessly around it, and never quite falling in. We do not feel the falling, of course. We feel still. We feel as though the ground is fixed, and the sun is the thing that moves, rising and setting, climbing and sinking, while we stay put. But it is the other way around, and it has always been the other way around. You are spinning right now, faster than any vehicle you have ever ridden in. And the whole spinning planet is racing along its orbit at nearly 19 miles every second, the entire time, never slowing, never stopping, held on its leash by the star at the centre of it all. This is the relationship you were born into and will die inside of. Total dependence on a thing you cannot touch, cannot reach, cannot influence in the slightest, and cannot live without for even a few weeks. Take the sun away, and the earth would not slowly grow chilly. It would die with a speed that is genuinely difficult to comprehend. Within days the surface would freeze. Within weeks the oceans would begin to ice over from the top down. The air itself would eventually fall as frozen snow. Every living thing that depends on warmth, which is to say every living thing, would be gone long before the planet wandered off, unbound, into the permanent dark between the stars. So when you look up at that soft and ordinary circle, understand what you are actually looking at. You are looking at the single most important object in your existence. You are looking at the reason you are warm tonight. And you are looking, though you would never guess it from how peaceful it seems, at one of the most violent places that has ever existed within reach of this planet. Because that gentle light, that quiet golden warmth, is the calm and distant face of something that is, underneath, almost beyond imagining in its fury. To understand why it could one day reach out and harm us, you first have to understand what it is doing every second of every day just to keep itself alive. You have to go inside. Part 2. The furnace beneath the calm. The surface of the sun, the part you can see, the part the light comes from, sits at a temperature of around 5,500 degrees. That alone is enough to vaporize anything we have ever built. Any rock, any metal, anything at all. There is nothing solid there to stand on. The whole star is gas and plasma, a fluid of stripped atoms so hot that the electrons have been torn away from their nuclei and everything moves as a sea of charged particles. But the surface, as ferocious as it is the cool part. It is the skin. It is the calm outer layer of something far worse. Travel inward. Down through the outer layers, where vast columns of hot plasma rise and fall in slow churning loops, each one larger than entire countries, each one a cell of boiling star that lives for a few minutes and then sinks back down to be reheated. The whole bright surface of the sun is covered in these cells, a constantly shifting mosaic, like the top of a pot of soup at a rolling boil, except each bubble could swallow the earth without noticing. Down further, the temperature climbs, and the pressure climbs with it, and the deeper you go, the more crushing and the more furious it becomes, until you reach the place that matters most. The core. In the core of the sun, the temperature is around 15 million degrees. The pressure is hundreds of billions of times the pressure of the air around you. Matter there is squeezed so tightly that it is more than 10 times denser than solid lead, and yet it is not solid at all, because it is far too hot to be anything but a screaming plasma. This is the engine. This is the place where the light is born. Here is what is happening in that core, every second, without pause, and has been for 4.5 billion years. The sun is taking the simplest atoms in the universe, hydrogen, the lightest thing there is, and it is crushing them together. Under that unthinkable pressure and heat, hydrogen nuclei are forced into one another and fused into helium, and in that fusing, a tiny fraction of their mass is lost, converted directly into energy. It is the most efficient and powerful process the universe has on offer. It is the same reaction that powers the most destructive weapons our species has ever built, except in the sun it is not a single flash. It is continuous. It is steady. It has been detonating, in a sense, for longer than there has been life on Earth, and it will keep detonating for billions of years more. The numbers do not really fit inside a human head, but try anyway, gently, the way you might hold a stone before letting it sink into water. Every single second, the sun fuses around 600 million tons of hydrogen. Every second. And in doing so, it converts roughly 4 million tons of matter directly into pure energy. Every second, and has done so without resting for the entire history of our world. The sun is, quite literally, lighter at the end of this sentence than it was at the beginning, and lighter still by the time you finish the next breath, shedding 4 million tons of itself into light and heat, with every tick of the clock. That energy is born deep in the core as radiation, as raw light. But it cannot simply fly out. The sun is so dense, so thick with matter, that a single particle of light created in the core cannot travel in a straight line for more than a tiny fraction of an inch before it slams into something, is absorbed, and is spat back out again in a random direction. And then again. And again, bouncing, scattering, wandering, taking the longest and most aimless journey imaginable, drifting slowly outward through layer after layer of the star. The light that warms your skin was created in the heart of the sun an almost unimaginable span of time ago, by some estimates many tens of thousands of years, struggling outward the entire time before it finally broke free of the surface and crossed the dark to reach you in 8 quiet minutes. The warmth on your face tonight is, in part, older than your entire civilization. It began its journey before the first city was ever built, and it arrives just in time to help you fall asleep. And then there is the strangest thing of all, the thing that even now we do not fully understand. Above the visible surface lies the sun's outer atmosphere, a faint and ghostly halo called the corona, the part you can only see during a total eclipse when the moon covers the bright disk and reveals the pale crown of light streaming around it. By every reasonable expectation, that outer atmosphere should be cooler than the surface beneath it. As you move away from a fire, you get colder, not hotter. But the sun does the opposite. The surface sits at around 5,500 degrees, and then, as you move outward into the corona, the temperature does not fall. It soars. It climbs into the millions of degrees, hundreds of times hotter than the surface it sits above. It is as though you stepped back from a campfire and found the air growing more scorching the farther away you walked. We have theories about why. We have ideas involving the sun's tangled magnetic fields dumping their energy into the thin outer gas. But the honest truth is that one of the most basic facts about our nearest star, the question of why its outer atmosphere burns so much hotter than its surface, is still not completely solved. This is the thing you live beside. A sphere of fusing plasma 1,000,000 times the size of your world, shedding 4 million tons of itself into light every second, wrapped in an atmosphere hotter than its own surface for reasons we cannot fully explain, holding itself together by the simple fact that its crushing gravity and its outward fury happen, for now, to be in perfect balance. For now, because that balance is not as quiet as it looks. And the place where it stops being quiet, the place where the sun's hidden violence breaks out into the open and turns its face toward us, is in something we almost never think about. The sun has weather, and its weather can reach across the void and find us. Part 3. The sun's weather. We are used to weather. We understand it in our bones. The sky darkens, the wind picks up, the rain comes, and then it passes, and the calm returns. We have built our whole lives around the rhythm of it. But it would never occur to most of us that the sun has weather too, that the star is not a smooth and steady lamp, but a stormy and temperamental thing, with seasons and cycles and sudden violent outbursts of its own. And unlike our weather, which is trapped down here in the thin shell of air around the planet, the sun's weather does not stay home. It can travel. It can cross the entire distance between us and arrive at our door. It begins with magnetism. The sun, that vast ocean of charged plasma, is also a vast and complicated magnet. As it spins, and it does spin, completing a rotation roughly once a month, it does something a solid ball could never do. It spins unevenly. The plasma at its equator races around faster than the plasma near its poles, so that the middle of the sun laps the top and bottom again and again, over and over, year after year. And because that plasma carries the sun's magnetic field along with it, that uneven spinning slowly winds the magnetic field up, twisting it, stretching it, knotting it tighter and tighter like a rubber band wound past the point of comfort. Sooner or later, something has to give. The tangled magnetic field punches up through the surface in great loops and arches, and where it breaks through, it chokes off the rising heat from below, leaving patches of the surface cooler and therefore darker than the blazing plasma around them. We call these darker patches sunspots. They look small and harmless from here, little freckles on the face of the star, but many of them are larger than the entire Earth, some many times larger, and each one marks a place where the sun's magnetic field has become dangerously, beautifully knotted. A sunspot is not a calm thing. It is a region under tension. It is a coiled spring. It is a place where an enormous amount of energy is being held in a configuration that desperately wants to snap back into something simpler. This whole process rises and falls in a great slow rhythm, a cycle that runs for about 11 years from one quiet stretch to the next. There are years when the sun is sleepy, its face nearly clean, its magnetic field relatively untangled, when the storms are few and mild. We call that solar minimum. And then, slowly, the tangling builds, the sunspots multiply, the face of the sun grows mottled and angry, and the storms come more often and hit harder. We call that solar maximum. And here is a small detail worth holding on to as you drift, because it makes all of this less abstract than it might seem. We are living near one of those peaks right now. The current cycle has been climbing toward its maximum across the last few years, an unusually busy one, busier than forecasters expected, with that heightened activity expected to linger before the sun begins, once again, to quiet down. We are not talking about ancient history or distant possibility. We are talking about the state of the star tonight. When one of those coiled, tangled magnetic regions finally snaps, it releases its stored energy all at once, in two very different ways, and the difference between them matters enormously for us. The first is the flare. A solar flare is a sudden brilliant flash, an explosion of light and radiation across every wavelength, including intense bursts of ultraviolet and X-rays. A large flare can release, in a matter of minutes, more energy than our entire civilization has used in all of recorded history. And because a flare is made of light, it travels at the speed of light, which means it crosses the gap to Earth in the same 8 minutes that ordinary sunlight takes. There is no warning. By the time our instruments detect a major flare, its radiation has already arrived. It floods the upper atmosphere, it can black out radio communications across the daylight side of the planet, it can scramble the signals our navigation systems depend on. The flare is the flash of the gun. The second is heavier, and slower, and far more dangerous. When the sun's magnetic field tears open, it can hurl an enormous mass of its own plasma outward into space, a cloud of charged particles weighing billions of tons, carrying its own twisted magnetic field tangled up inside it. We call this a coronal mass ejection. It is not light. It is matter, a vast belch of the sun's own substance flung off into the dark, and it travels far more slowly than light, taking somewhere between 1 and 3 days to make the crossing, though the fastest ones can cover the distance in well under a day. If a flare is the flash, the coronal mass ejection is the bullet. And if that bullet is aimed at us, if it leaves the sun on a trajectory that intersects the place our planet will be when it arrives, then we have, at most, a day or two of warning before billions of tons of magnetized solar plasma slam into the invisible shield that surrounds our world. That shield is real, and it is the only reason any of this is survivable. The Earth has a magnetic field of its own, generated deep in its molten metal core, and it reaches far out into space and wraps the entire planet in a protective bubble. When the solar wind blows, and it always blows, that bubble deflects it, channels it, keeps the worst of it away from the surface. It is the reason we are not slowly stripped of our atmosphere the way Mars seems to have been. It is the guardian we never see and never thank. But a guardian can be overwhelmed. When a fast, dense, powerfully magnetized cloud of plasma crashes into Earth's magnetic shield, it compresses it, squeezes it, pushes it inward, and pours its energy into it. The shield shudders. Currents surge through it. The whole structure rings like a struck bell. We call the result a geomagnetic storm, and most of the time it produces nothing more than a light show, the auroras, those curtains of green and red that dance over the far north and the far south when the sun's particles spill down along the magnetic field lines and crash into the upper air. Beautiful, harmless, a gift. Most of the time. But not every time. Because every so often, the cloud that hits us is not ordinary. Every so often, the sun aims something at this planet that does not produce a gentle light show, but something that reaches all the way down to the ground, into the very wires and machines we have wrapped around our civilization, and reminds us in a single night how fragile the modern world truly is. It has happened before. The first time we were ever able to witness it and write it down was more than a century and a half ago, on a quiet late summer day, when a man with a telescope watched the sun do something no human had ever recorded, and the world below lit up in ways no one could explain. Part 4. The night the wires came alive. On the morning of the 1st of September, in the year 1859, an Englishman named Richard Carrington was doing what he did most clear mornings. He was studying the sun. Not by looking at it directly, which would have blinded him, but by letting its image fall through his telescope onto a screen, where he could safely trace the dark scattering of sunspots that crossed its face. He had been watching one particularly large and complicated group of spots for days, and on this morning, as he sketched, something happened that no human being had ever knowingly seen before. 2 points of intense white light suddenly blazed into being over the sunspot group. They were so bright that for a moment Carrington thought a beam of ordinary sunlight had somehow broken through and struck his apparatus. He glanced away and back, and they were still there, brilliant and unmistakable, kidney-shaped patches of pure radiance flaring above the spots. They brightened, peaked, and then within a few minutes faded away. He had just become the first person in history to witness a solar flare, to watch the sun release a portion of its stored magnetic fury in real time. He did not know what he was seeing. No one could have. The science to explain it would not exist for generations, but he recorded it carefully, faithfully, a quiet man at a telescope writing down the opening line of a story, whose ending we are still living inside. What Carrington could not see was what came after. Because that flare had been accompanied by something far larger, an immense cloud of solar plasma flung off the sun and aimed, as it happened, almost directly at Earth. And this cloud was fast. Where a typical eruption might take 2 or 3 days to make the crossing, this one tore across the gap in well under a day. While Carrington slept that night, billions of tons of charged solar matter were closing on the planet at a speed that would deliver them in a matter of hours. They arrived in the small hours, and the sky came apart. Across the world, in places that had never seen such a thing and would never see it again in their lifetimes, the night lit up. The auroras, those polar curtains of light that normally hide far away near the top and bottom of the world, came pouring down toward the equator. They were seen over the Caribbean. They were seen over Cuba, over Hawaii, over Colombia, in latitudes where the very idea of the northern lights was a traveller's tale, a thing that happened to other people in other lands. The glow was so intense, so vivid, that in the northeastern United States people reported being able to read a newspaper outdoors by its light alone, in the middle of the night, as though a strange cold dawn had risen at the wrong hour. In the mountains of the American West, gold miners woke from their sleep, saw the brilliant sky, and assumed the sun had come up. They rose and dressed and began to cook their breakfasts in the dead of night, fooled by a light that was not the sun at all, but the sun's plasma burning in our own air. It was beautiful. People stood in the streets and watched. For most of them it was a wonder, a spectacle, a story they would tell for the rest of their lives. But while they watched the sky, something was happening in the one piece of electrical technology the world had so far built, and that something was the first warning we ever received about the age that was coming. In 1859, humanity had almost no electrical infrastructure. There were no power grids, no electric lights in homes, no wires running into people's walls. There was only one significant electrical network on the entire planet, and that was the telegraph, the thin web of wires strung between cities that carried messages in clicks and pulses, the cutting edge of communication for its day. And the telegraph went mad. The same storm that was painting the sky was pouring its energy into those long telegraph wires, inducing powerful electrical currents in lines that had never been designed to carry them. Sparks leapt from the equipment. Operators received sharp electric shocks. In some offices, the telegraph paper caught fire from the heat of the unexpected currents. And then came the detail that has haunted scientists ever since. The detail that should make you understand, lying there in the dark, just how much raw power was loose in those wires that night. In several places, operators discovered that they could disconnect their batteries entirely, cut off the only power source the system was supposed to have, and still send messages. The lines were so charged by the storm itself, so full of the sun's energy flowing through them, that the telegraph kept working on the aurora alone. The technology was being driven by the sky. This is the event we now call the Carrington event, named for the quiet man at his telescope, and it remains, to this day, the benchmark, the most powerful geomagnetic storm ever directly recorded, the high water mark against which every solar storm since has been measured. The best estimates of its strength range from something already extreme to something almost twice as extreme again, a storm so violent that we are honestly not certain of its upper limit, only that it dwarfs anything the modern world has lived through. And here is the thought that turns the wonder into something colder. In 1859, all that immense power had almost nothing to grab onto. A handful of telegraph wires. That was the entire surface area the storm could find to pour itself into. The world was made of wood and stone and horses and candlelight. A storm of that size could rage across the planet, and the worst it could do was set some telegraph paper alight and shock some operators and light up the sky. There was simply nothing else for it to break. That is not the world you are living in tonight. The world has changed beyond all recognition since that September night. We have spent the last 160 years doing the one thing that turns a Carrington storm from a beautiful curiosity into a catastrophe. We have wrapped the entire planet, every continent, every city, every home, in an unbroken web of wire and metal and delicate electronics, all of it exquisitely sensitive to exactly the kind of currents that storm induced. We have built, without ever quite meaning to, the perfect thing for the sun to break. The Carrington event was not the last of its kind. It was simply the first one we were able to watch. And the storms that followed, the ones that came after we had begun to build our electrical world, started to show us in pieces what such a night would actually cost. We did not have to wait long or look far for the first real demonstration. Part 5. The Modern Warnings. It was the middle of a cold March night in 1989, and across the Canadian province of Quebec, more than 6 million people were asleep, exactly as you are settling towards sleep now. They had no reason not to be. There had been some talk of solar activity, the way there sometimes is, but nothing that touched the lives of ordinary people. Nothing that anyone lying in a warm bed needed to think about. The sun had thrown a large cloud of plasma toward Earth a day or two earlier, and that cloud was now arriving, pressing against the planet's magnetic shield, pouring its energy into the bubble that surrounds us. That energy did what such energy does. It induced powerful electrical currents in long conductors, and the longest conductors in the modern world are the great high-voltage power lines that carry electricity across hundreds of miles from the places it is generated to the cities that drink it. Quebec's grid, drawing its power from enormous hydroelectric stations far to the north and pushing it south along immense transmission lines, was almost perfectly built to catch the storm. The induced currents surged into the system. The grid's automatic protections, sensing that something was deeply wrong, began to trip, one safeguard after another snapping open to protect the equipment. And then, in the space of about 90 seconds, the entire power grid of an entire province collapsed. Not a neighbourhood, not a city. The whole thing, all at once, in a minute and a half, in the depth of a winter night. 6 million people lost their electricity in their sleep. They woke into cold and darkness, in a climate where cold is not an inconvenience, but a danger. There was no light, no heat, no working transit, no power for the pumps and systems a modern city quietly depends on. It would take around 9 hours to bring the grid back. 9 hours of a frozen province trying to function without the invisible river of electricity it had forgotten it was standing in. And the storm did not stop at the border. Far to the south, at a power station in New Jersey, a massive transformer was damaged so badly by the same event that it had to be replaced. That was 1989. The strength of that storm, measured on the scale scientists use, was severe, genuinely severe, the worst of its era. And yet, set against the Carrington event of a century earlier, it was perhaps only a fraction as powerful. A storm a small fraction the size of the Great One had just switched off the lights for 6 million people in 90 seconds. The lesson was sitting right there in the dark for anyone willing to read it. Our grids are not separate from the sky. They are antennas, and the sun, when it chooses, can play them. A little over a decade later, the sun offered another demonstration, this one spread across the world. In the final days of October in 2003, during a period of furious solar activity, the sun unleashed a barrage of enormous flares and a parade of plasma clouds, one after another, in such quick and violent succession that the events earned their own name. The Halloween storms. Among them was a flare so powerful that it overwhelmed the very instruments built to measure it, forcing scientists to estimate just how large it truly was. placing it among the most intense flares ever recorded by human beings. The wave of storms swept over the planet. In Sweden, a city lost its power. Tens of thousands of people plunged briefly into darkness by currents the sun had induced in their grid. Around the world, airlines began rerouting flights away from the polar regions, where the radiation was climbing and the communications were failing. Paying real money and burning real fuel to steer human beings away from the invisible storm pouring down at the top of the world. In orbit, satellites suffered. Some were knocked offline temporarily. Some were damaged. At least one, a sophisticated spacecraft watching the Earth's environment, was effectively killed, its working life ended early by the radiation. And aboard the International Space Station, the astronauts took shelter in the most shielded parts of their home, waiting out the worst of the particle storm in the safest corner they had, because the thin metal walls that normally protected them were no longer protection enough. Auroras spilled far down from the poles again, into latitudes that rarely see them, and once more people stepped outside to marvel at a sky that had no business glowing the way it was. Beautiful, as always. The sun's violence almost always arrives dressed as beauty. That is part of what makes it so easy to forget how dangerous it is. These were the warnings. Quebec and the Halloween storms, and a scattering of smaller events between and around them. Each one was a note from the sun, written in the only language it has, the language of induced currents and failed satellites and darkened cities, telling us the same thing over and over. I can reach you. I can find the things you have built. And what you have seen so far is not the largest thing I can do. But none of these, not Quebec, not the Halloween storms, came close to the true ceiling. None of them came close to a Carrington. To understand how close we have actually come to that, in our own modern age of wires and satellites and screens, you have to know about a day that almost no one noticed at the time. A day when a storm fully the equal of the Great One of 1859, perhaps even greater, was launched directly across our orbit. A storm that would have changed the world. And the only reason it did not, the only reason you have likely never heard of it, is a matter of timing so narrow it is difficult to believe we were that lucky. Part 6. The Bullet That Missed. The 23rd of July, 2012. It was an ordinary summer, by every measure that the people of Earth could see. The news carried the usual stories. Life went on, as it does, and 93 million miles away, on the far side of the sun from where our planet happened to be sitting, the star did something that, had the geometry been only slightly different, would have rewritten the history of this century. It launched a coronal mass ejection of extraordinary size and almost unbelievable speed. A typical such cloud crawls across the gap to Earth over 2 or 3 days. This one was moving at around 3,000 kilometers every second, more than 4 times the usual pace. Fast enough to make the crossing in well under a day. Part of the reason it could move so fast was a quiet bit of cosmic preparation. 2 smaller eruptions had gone out ahead of it just before, sweeping the path mostly clear of the ordinary solar wind that normally slows these clouds down, so that this great one could race outward almost unimpeded, like a runner finding the track suddenly empty in front of them. It tore straight through the region of space where Earth's orbit lies. It crossed the very path our planet travels. And the only reason it did not strike us, the only reason this is a story about a near miss rather than a story about the night the modern world ended, is that the Earth was not standing in that part of its orbit at the moment the cloud arrived. We had been there. We would be there again. By the calculations that came afterward, we missed a direct hit by something on the order of a week, perhaps 9 days, of orbital timing. In the great slow clock of a planet circling its star, the cloud and the world passed through the same doorway just slightly out of step, and we never felt a thing. But we did not miss it entirely, in the sense that matters most. Of all the places in the entire solar system that immense cloud could have flown into, of all that empty space it could have wasted itself in, it happened to slam directly into one of our spacecraft. A solar observatory, positioned far from Earth, built precisely to study the Sun, and equipped to survive and measure exactly this kind of event. It rode out the storm, and it recorded everything. And so, by an accident of placement, we have an exquisitely detailed picture of a monster that never touched us, a full reading of a bullet that passed through the space we had just vacated. When scientists studied that data, the conclusion they reached was sobering enough that some of them have spent the years since trying to make the rest of us understand it. The storm, had it hit, would have been a true Carrington-class event. By their estimates, it would have driven a geomagnetic storm fully comparable to the Great One of 1859, and roughly twice as severe as the storm that took down Quebec's grid in 90 seconds. This was not a large storm. This was the storm. The kind we had been treating as a once-in-a-very-long-while historical curiosity, and it had passed through our orbit in our own lifetimes, in the age of the internet and the satellite and the global power grid, and we had simply not been standing there to receive it. One of the researchers who studied it put the consequences in words that are hard to forget. If it had hit us, he said, we would still be picking up the pieces. Not for days, not for weeks. We would still, years later, be repairing what a single night had broken. And then came the part that should sit with you most heavily of all, gently, as a thing to understand, rather than a thing to fear. Once they had this detailed look at how often the Sun is capable of producing such an event, one scientist worked out the odds. He calculated the probability that a storm of Carrington scale would strike the Earth in any given 10-year stretch, and the number he arrived at was around 12%. 12% per decade, roughly 1 chance in 8, every 10 years, that the Sun will reach out and do to our wired and connected world what it did to a handful of telegraph lines in 1859. That is not a small number. It is not the kind of risk you can comfortably file away under things that happen to other generations. Spread it across the span of a single human life, across the decades you will live through, and the odds that you will personally be alive for such an event stop looking remote at all. The near miss of 2012 was not a reassurance that we are safe. It was the opposite. It was a measurement, taken in our own time, proving that the worst the Sun can do is not confined to old engravings and yellowed newspapers. It is a live possibility. Sitting in the sky above you right now, waiting only on the simple matter of when the geometry lines up. We have been lucky. That is the honest summary of the modern age. We have lived through a string of warnings, each one a little softer than the one that almost came, and we have come through them with darkened cities and dead satellites and grounded flights, but never with the true catastrophe. The bullet of 2012 missed. The storms that have actually struck us have all so far been the smaller cousins of the monster. And the most recent of those storms, the largest one to actually reach this planet in more than 20 years, arrived not in some distant decade but only a short while ago, on a spring weekend that millions of people remember not as a disaster but as the night the sky turned, impossibly. Pink and green over their own backyards. It is worth understanding exactly what happened then, because it is the closest thing we have, in recent memory, to a dress rehearsal for the night this whole story has been circling toward. Part 7. The weekend the sky turned. In the first days of May 2024, a region on the face of the Sun began to grow. It had rotated into view at the start of the month, and over the following days it swelled into something enormous. A sprawling, magnetically tangled complex of sunspots that eventually covered an area many times the size of the Earth. Somewhere in the range of 14 to 17 times our planet's own face laid across the surface of the star. Solar physicists watched it the way you might watch a storm cloud build on the horizon, knowing what such a thing can become. And it did become it. Over several days that vast region fired off a chain of powerful flares and flung out cloud after cloud of plasma. One coronal mass ejection after another, a barrage rather than a single shot. And here something happened that turned a serious event into a genuinely historic one. The clouds, launched in close succession, began to catch up with and merge into one another on their way across the void, combining their masses and their tangled magnetic fields into a single, larger, more powerful structure. By the time this combined storm reached Earth on the 10th of May, it had become the most severe to strike the planet in over 20 years, the first storm of the very highest category, extreme, since the Halloween storms 2 decades before. It was given a name. The Gannon storm, in memory of a respected space weather physicist who had died not long before, a quiet tribute woven into the record of the event itself. And for most of the people who experienced it, the Gannon storm was not a disaster at all. It was one of the most beautiful nights of their lives. Because the auroras came down, not just to the usual far northern and far southern lands, but down and further down still, into places that had not seen such a thing in living memory, or had never seen it at all. The light spilled across skies far from the poles, and millions of people who had only ever known the aurora as a thing you travelled to the ends of the earth to glimpse, simply walked out their front doors and looked up and found it waiting for them, draping the sky in slow ribbons of pink and violet and green. Phones came out everywhere. The images flooded across the world. For one weekend, an enormous fraction of humanity shared the same astonishment, looking up at the same charged and glowing sky, most of them with no idea that what they were admiring was the visible edge of a storm pouring billions of tons of solar particles against the shield around their world. But underneath the beauty, the storm was doing the quiet. Mechanical things that storms of this size do, and this time we were watching more closely than we had ever watched before. It has since been called the best documented geomagnetic storm in all of history, measured by more instruments, from more angles, in more detail than any solar storm that came before it. And what those instruments saw was sobering. High in space, the storm crushed one of the protective layers that surrounds the planet, a donut-shaped reservoir of charged particles that normally sits tens of thousands of kilometers above our heads. In the span of about 9 hours, the outer edge of that layer was squeezed inward to roughly a fifth of its usual distance, collapsing from something like 44,000 kilometers down to under 10,000, a structure that ordinarily changes only slowly forced to contract with shocking speed. Down on the ground, in the world we actually live in, the effects were smaller but pointed. In some places, high-voltage power lines tripped. Transformers, the great heavy hearts of the electrical grid, overheated. And out across the farmland of the American Midwest, something happened that captured, in a single homely image, exactly how deeply the sun now reaches into our ordinary lives. It was planting season, and modern farming, the kind that feeds hundreds of millions of people, leans heavily on tractors and equipment guided by satellite navigation, machines that steer themselves down dead straight rows with a precision no human hand could match, all of it depending on signals from space accurate to within a few centimeters. The Gannon storm scrambled those signals. The navigation that the machines relied on faltered and drifted, and across the Midwest, self-steering tractors began to veer off course, wandering from their perfect lines, some of them simply shut down by their operators who no longer trusted where the machines thought they were. Planting that had already been delayed by a wet spring was delayed further. For the farms that were affected, the losses came to something like $17,000 each, on average, real money lost from real livelihoods, because the sun had a bad weekend. Now hold both halves of this in your mind as you drift, the beauty and the cost together, because the Gannon storm is the most important recent fact in this entire story. It was the strongest storm in over 20 years. It crushed a protective layer of the planet to a fifth of its size. It tripped power lines and overheated transformers and steered tractors off their rows and cost farmers their money. It was, by any honest measure, a major event. And it was nowhere near a Carrington. That is the thing to understand. The Gannon storm, as historic and as beautiful and as costly as it was, did not even reach the extreme readings of the worst storms, let alone the readings estimated for 1859 or for the cloud that missed us in 2012. It caused no catastrophe. It broke no civilization. It gave us a glorious light show and a manageable bill and a great deal of valuable data. It was, in the language of warnings, a gentle one. So now you have the full shape of it. You know what the sun is, and what it can do and what it has done. You know that the small storms darken cities and kill satellites and confuse tractors. You know that the medium storms collapse entire power grids in 90 seconds. And you know that the largest storm we have ever measured tore through a world of telegraph wires, and the largest storm of our own age passed silently through the orbit we had just left. There is only one thing left to face, and it is the thing the whole story has been walking toward from the very first sentence. What actually happens, hour by hour, if a storm the size of the Great One arrives at the world we have built tonight, while most of that world is asleep? Let us walk through it slowly, calmly, all the way to the end, knowing the entire time that it is not happening, and that you are safe. Part 8. The Overnight. Begin with an ordinary evening. There is nothing special about it. The sun set a few hours ago wherever the story starts, painting the usual colours and slipping below the horizon, and the people there have gone about the small rituals of the end of a day. Somewhere on the other side of the world it is the middle of the afternoon, and somewhere else the sky is just beginning to lighten. The planet turns, as it always turns, and at any given moment half of it is in light and half of it is in darkness, and the people in the dark half are doing what you are doing now. Settling, slowing, preparing to sleep. The thing that will change everything has, by this point, already happened. Roughly a day earlier, on the face of the sun, a vast and tangled magnetic region reached the end of what it could hold and snapped. A flare blazed out, the radiation crossing to Earth in 8 minutes and washing over the daylight side, scrambling some radio, nudging some signals, the kind of thing that happens often enough that it caused no alarm. But behind the flash came the mass. A cloud of magnetized plasma of the very largest kind, billions upon billions of tons of the sun's own substance, flung outward at tremendous speed and aimed. This time, not at the empty space beside us, but directly at the place the Earth would be. It has been crossing the void for the better part of a day. And now it is nearly here. We can see it coming. That is the strange mercy of the modern age, the thing the people of 1859 did not have. Far out ahead of the Earth, on the line between us and the sun, sits a small spacecraft, a sentinel parked at a special point of balance about 1,000,000 miles sunward, watching the solar wind blow past and measuring it. When the great cloud reaches that sentinel, the spacecraft will read it, and that reading will race back to Earth at the speed of light and tell us what is about to arrive. But the sentinel sits only 1,000,000 miles out, and the cloud is moving so fast that the warning it gives is not measured in days or even hours. It is measured in minutes, perhaps half an hour, perhaps a little more. That is the entire head start the most advanced civilization in the history of this planet has against the largest storm its star can throw. And there is a cruelty hidden inside even that brief warning. The amount of damage a storm does depends enormously on one thing that we cannot know until that final moment. It depends on which way the magnetic field tangled inside the cloud is pointing when it arrives. If it points one way, aligned with the Earth's own field, the cloud will largely slide past, its energy mostly deflected. And even a giant storm may do far less than its size suggests. But if it points the other way, opposed to the Earth's field, the two will lock together and couple with terrible efficiency, and the cloud will pour its full fury straight into the planet's shield. We do not learn which it is until the cloud reaches the sentinel, so for the entire day that the storm has been crossing the void, we have known it was coming, and we have not known whether it would be a light show or a catastrophe, and we will not know until the last half hour. The dice, as one description of an earlier storm put it, are already in the air. We are simply waiting to see how they land. In this story, they land the wrong way. The sentinel reads the cloud and sends its warning, and in operation centres around the world the alerts go out, the highest level, the rarely used one. There is almost nothing left to do. You cannot unbuild the grid in half an hour. You cannot shield a continent of transformers in the time it takes to make a cup of tea. The few who understand what is coming brace for it, and the billions who do not sleep on, unknowing, in the dark half of the turning world. And then it arrives. The cloud strikes the magnetic shield around the Earth and crushes it inward, compressing the bubble that has protected this planet for billions of years, pushing it closer to the surface than it has been in a very long time. The shield rings with the impact. Enormous electrical currents begin to flow through the upper atmosphere, vast rivers of charged particles circling the poles, far stronger than anything in an ordinary storm. The auroras flare into life and come pouring down, not staying near the poles, not stopping at the latitudes the Gannon storm reached, but sweeping down and down toward the equator, lighting up skies that have not glowed like this since the night the gold miners cooked their breakfasts in the dark. Anyone awake to see it would never forget it. The whole sky alive, rippling, the colour of it impossible, beautiful beyond description, and almost no one watching would understand that the beauty is the storm finding the ground. Because as those immense currents flow overhead, they induce currents below, in every long conductor the storm can reach. And the longest conductors on Earth are the great transmission lines of the power grids, the steel and copper arteries that carry electricity across whole continents. Into those lines the storm pours a kind of current they were never built to handle, a slow, heavy, direct current flowing where only the grid's own carefully balanced alternating current should be. It seeps into the transformers, the enormous machines that step the voltage up and down at every junction of the grid, the heavy beating hearts of the whole system, and it begins to overheat them. This is the quiet centre of the catastrophe, and it is worth understanding clearly, because it is not loud, and it is not dramatic in the way a storm on the ground is dramatic. It is just heat, building in metal where it does not belong. The great transformers begin to saturate and warm further, and in the worst of them the heat climbs past what the insulation can bear, and they begin to fail. Not by the dozen, potentially by the hundreds across many countries in the same night. And here is the part that turns a long blackout into something far longer. These largest transformers are not kept in warehouses by the thousand. Each one is enormous, the size of a house, custom built, weighing hundreds of tons, often made to order over many months by a small number of factories in the world. You cannot run to a store for one. You cannot swap one in by morning. When a great transformer dies, replacing it is the work of many months, sometimes longer. And if hundreds die in a single night, all needing replacement at once, from a supply chain that can only make so many a year, then the arithmetic becomes very grim, very quietly. So the grids trip and fall. The protections do what Quebec's protections did in 1989, snapping open to save what they can, and across vast regions the lights go out, the way they went out for 6 million people in 90 seconds. Except now it is not one province on one cold night. It is potentially much of a continent, or several, in the same handful of hours, while most of the people it is happening to are asleep and have no idea that the warm hum of the world has just stopped. You would not feel the moment it happened. That is perhaps the strangest thing to sit with. There would be no explosion, no sound, no shaking. Somewhere above the clouds the sky might be glowing in colours you had never seen. But inside, in the dark, the only sign would be the smallest one. The quiet click of everything switching off at once. The refrigerator going silent. The little lights on the devices around you winking out. A stillness where there is always, usually, the faintest electrical hum. You might sleep right through it. Most people would. They would wake in the morning into a world that looked almost exactly the same as the one they fell asleep in. The same walls, the same window, the same sky going light, and it would take them a while. A strange and lengthening while, to understand that almost nothing was going to work that day, or the next, or for a long time after. The storm would already be over, the sun would already be calming, the cloud would have swept past, and the auroras would have faded, and the sky would be ordinary again. And the consequences would just be beginning. Part 9. The long dark. We tend to imagine a power cut as an evening. A few hours of candles and patience, a small adventure, and then the lights flicker back and the world resumes. That is what a power cut has always been, in our experience, because that is what the grid has always been able to deliver. The failures we know are brief and local, a storm that brings down a line, a fault that trips a substation. And somewhere a crew goes out and fixes the broken thing, and the river of electricity flows again before the food in the refrigerator has had time to spoil. A storm of the kind we have been walking through would not be that. It would not be an evening. And the reason has nothing to do with the storm itself, which would be long gone, and everything to do with the thing it broke. When the great transformers fail by the hundreds, and there are not hundreds of spares, and they cannot be built quickly, then the grid does not come back that night, or that week, or perhaps that season. It comes back slowly, region by region, as the few replacements that exist are found and moved and installed, and as new ones are built in the time it takes to build them. The darkness in the worst affected places could last not for hours, but for many months. And almost everything in the modern world is quietly arranged on the assumption that this will never happen. Walk through it gently, not as a fear but as an understanding, because seeing how the pieces connect is its own kind of calm. The first thing most people would discover is that the water stops. We think of water as something that simply arrives when we turn a tap, but in most cities it arrives because electric pumps push it through the pipes and up into the towers and into the buildings. No power, no pumps. No pumps, and within a day or two the taps run dry and the toilets will not flush. In the great dense cities where millions of people live stacked in the air with no well to draw from and no river close enough to carry from, the most basic function of a body, the need for clean water, suddenly depends on a grid that is no longer there. Then the food. Not the food in your kitchen, which would last a little while, but the system that keeps food coming. The vast network of refrigeration that keeps the world's food from spoiling runs on electricity. The trucks that move it run on fuel, and the fuel is pumped from underground tanks by electric pumps at stations that cannot pump without power. And the payments for all of it move through systems that need the grid and the network to function. The shelves of a modern store are not a storehouse. They are the visible end of a constantly flowing river of deliveries, restocked every day or two, holding only what a city eats in that short window. Stop the river, and the shelves empty within days, and there is no great reserve behind them waiting to be opened. And underneath all of it runs the thread that ties every other thread together, which is information. The phones, the internet, the networks, the quiet digital nervous system that now coordinates almost every action of modern life. All of it needs power, and the backup batteries and generators that protect the most important pieces of it are measured in hours and days, not months. As they run down, the ability to coordinate runs down with them. The ability to know what is happening, to call for help, to organize the repair, to tell people what to do and where to go. All of that becomes harder exactly when it is needed most. This is what the people who study these things mean when they talk about cascading failure. No single broken piece is the disaster. The disaster is that every piece needs the others. The water needs the power repair needs the fuel needs the power and the payment systems. The payment systems need the networks need the power. Each system was made strong on its own, resilient, well defended, but each was built leaning on the assumption that the others would be standing, and a storm large enough takes them all down in the same night, and then there is nothing for any of them to lean on. The margins we rely on, the quiet redundancies, the assumption that you can always borrow strength from a neighbouring system. All of it erodes at once. When people have tried to put a number on what such an event would cost, the figures stop meaning very much, because they are so large. Serious studies have estimated that a severe storm of this kind could do economic damage measured in the trillions in just the first year, with the full recovery stretching out across something like 4 to 10 years. Years, not because the storm itself lasts more than a day, but because rebuilding the broken heart of an electrical civilization while that civilization is struggling to function without it, is simply slow. It is comparable, some have said, to a great natural disaster, except that instead of striking one city or one coast, it strikes entire continents at the same moment, with no untouched neighbour close enough to rush in and help. And the hardest part, the part that the people who understand this carry around quietly, is that we are not really ready, and we know it. The grid we depend on was built in the gentler decades, designed when space weather was a curiosity for scientists rather than a planning assumption for engineers. The protections that could shield the great transformers from these slow-induced currents exist. We know how to build them. The hardened equipment, the blocking devices, the better forecasting, all of it is within reach. But it is expensive, and it must be paid for before the disaster rather than after. And spending money before a disaster has always been the hardest thing for any society to do. So the upgrades come slowly, in pieces here and there, far slower than the 12% per decade would suggest they should. I am not telling you any of this to frighten you, lying there in the warm and the quiet. I am telling you because it is true, and because there is a strange peace in understanding the real shape of the world rather than the comfortable cartoon of it. The lights are on tonight, the water is running, the sun is calm. The storm in this story is not happening, and may not happen in your lifetime at all, and even if some version of it did, you would most likely sleep through the moment it began, and wake to a long, strange morning rather than a sudden end. The point of walking through the long dark is not to make you afraid of it. It is to make you feel, just for a moment, how thin and how precious the ordinary working of the world actually is, so that the simple fact of a humming refrigerator and a glowing screen becomes, briefly, a small miracle worth noticing before you let it go. Part 10. Why we cannot simply stop it. A natural question rises here, the same one that rises with any great threat. If we know this is possible, if we know roughly how often it could happen, why can we not simply see it coming far enough in advance to be ready? We forecast hurricanes days ahead. We track asteroids years out. Why is the sun the one thing we cannot get ahead of? Part of the answer is that we are watching, and far more closely than we once did. But the sun is enormous, and we are small, and there is only so much of it we can keep our eyes on at any one time. We have spacecraft staring at the sun constantly, watching its surface for the tangled regions that breed storms, catching the flares as they erupt, tracking the great clouds as they billow outward. We are not blind. The people of 1859 were blind. We are not. But there is a deep limit built into the geometry of the whole situation, and no amount of cleverness has fully solved it. The sun turns. It rotates roughly once a month, carrying its surface around and out of our view, so that at any given time we can only properly see the side of it that happens to be facing us. The far side, the half turned away, is largely hidden, and a magnetic region does not wait politely on the near side until we are ready for it. It can grow and tangle and load itself with energy on the far side, out of our sight, and then rotate into view already dangerous, already capable, a storm we did not watch develop because it developed where we could not look. We have tried to fill that blind spot. We have flown craft to vantage points off to the side to glimpse around the edge, and there is much talk of doing more, of stationing more sentinels around the sun so that we are never looking at only half of it. But for now, a good part of the time, we are watching a turning sphere and seeing only the face it shows us. Even when we do see a storm launch, even when we catch the great cloud heading our way, the most important question remains unanswerable until the very end. We can measure the cloud's speed and its size and its direction. We can tell that it is coming, and roughly when it will arrive, often a day or so ahead. But the single thing that decides whether it will be a glorious light show or a continent-darkening catastrophe, the orientation of the magnetic field knotted up inside it, cannot be reliably read from far away. We only learn it when the cloud sweeps past the sentinel parked 1,000,000 miles ahead of us, and by then the warning is down to roughly half an hour. We get a day of knowing something is coming, and 30 minutes of knowing how bad it will be. The forecast and the impact are almost the same moment. There is a reason for that small lonely outpost being where it is. 1,000,000 miles sunward of the Earth lies a special point, a place where the pull of the sun and the pull of the Earth balance in just the right way that a spacecraft can sit there, more or less holding station, keeping a steady watch on the wind blowing past before it reaches us. It is the best forward position we have, the closest thing to a watchtower on the road the storms travel. But 1,000,000 miles against a cloud moving at hundreds or thousands of miles every second buys only those few minutes. It is a watchtower so close to the gate that the warning shout and the arrival of the army come almost together. And so the honest picture is this: we are not helpless and we are not blind, but we are working against a problem that has hard edges we cannot easily push past. We cannot see the whole sun at once. We cannot fully read a storm until it is nearly upon us. We cannot build a wall in the half hour we are given. The things we genuinely could do, the hardening of the grid, the protecting of the transformers, the building of more watchtowers around the sun, are all things that must be done slowly, in advance, in the long quiet years between storms, paid for out of ordinary budgets in ordinary times when the sky looks perfectly calm and the threat feels like a story. Which is to say, paid for on nights exactly like this one. There is something almost humbling in it, and the humility is worth resting in for a moment. We have mapped the genome and split the atom and sent our machines to the edge of the solar system and beyond. We have wrapped our whole world in instant communication and lit our nights as bright as day. And yet the oldest and largest object in our sky, the one we depend on most completely, remains something we can watch but not predict with certainty, study but not control, prepare for but not prevent. The sun does not negotiate. It does not announce its intentions. It simply does, on its own schedule, in its own time, what a star of its kind does, and the most we can do is keep watch and try, in the calm years, to make ourselves a little harder to harm. But all of this, the storms and the grids and the trillions and the long dark, all of it is really a story about one thin and recent thing. It is a story about our technology, about the fragile electrical skin we have grown across the planet in the last blink of time. The storm does not threaten the Earth. It does not threaten life. It does not even truly threaten us as creatures. It threatens the machines and our dependence on them. And to see that clearly, to set it in its true proportion, you have to step back, much further back, and look at the sun not as a threat at all, but as the thing it has been for almost all of its long life, and almost all of ours. Not the destroyer. The source. Part 11. The maker, not the enemy. For the last hour we have been speaking of the sun as a danger, and it is one. But that is the smallest and rarest face of it, the once-in-a-century scowl on a face that has smiled on this world without pause for billions of years. If you measured the sun's whole existence and counted up all the harm it has ever done us against all the good, the harm would not even register. The truth, the deep and steady truth underneath the dramatic one, is that the sun is not the thing most likely to destroy you. It is the thing that made you, and that keeps you, every second, alive. Consider what it is doing right now, even in the dark, even on the night side of the world where you cannot see it. The warmth held in the ground and the air around you tonight is its warmth, soaked up during the day and slowly released. The reason the night is merely cool and not lethally, airlessly cold, the way the night truly is, just a little way above the atmosphere. The breath you are taking as you settle came from plants, and the plants built themselves and the oxygen in that breath out of sunlight, weaving air and water into living tissue using energy poured down from the sun. Every green and growing thing on the planet is in a sense a small slow machine for catching sunlight, and every creature that has ever lived has lived, directly or at one remove, on what those machines caught. The food that kept you alive today was sunlight not long ago, gathered by some plant, perhaps eaten by some animal, passed along the chain until it reached you. The weather that moves across the world, the winds and the rains and the great turning of the storms, is the sun's heat stirring the air and lifting the water from the seas and carrying it across the land to fall again as rain. The rivers run downhill because the sun lifted their water into the sky in the first place. Even the energy locked in coal and oil, the fuel of the very civilization the sun could one day darken, is ancient sunlight, captured by living things in the deep past and buried and pressed and saved across unimaginable stretches of time. Nearly every source of energy and warmth and life this planet has ever had traces back, when you follow the thread far enough, to that one star. And there is the deepest gift of all, the one we almost never think of, hidden in the very calm we take for granted. The sun is a remarkably steady star. There are stars in the sky that flare and pulse and shudder, that double their brightness and halve it again, that would never permit anything as delicate as life to find a foothold in their light. Ours does not do that. For billions of years it has held its output nearly constant, varying only by the tiniest fraction across its great slow cycle, warming the earth with a patience and a reliability that is, when you really consider it, astonishing. Life is fragile. It needs its conditions to hold steady across enormous spans of time. And the sun has held them steady, hour after hour, year after year, age after age, since long before there was anyone here to be grateful for it. The whole vast experiment of life on this world, every creature that has ever crawled or swum or flown or dreamed, was only ever possible because one particular star happened to be calm enough, and steady enough, and kind enough, for long enough. So the same star, hold that. It is the same star in both halves of this story. The thing that could pour its fury into our wires for a single terrible night is the very thing that has fed and warmed and steadied this world across 4.5 billion years. There is no contradiction in it. It is simply what a sun is, and it has never pretended to be anything else. It is not for us. It does not warm us on purpose or threaten us out of malice. It is a vast and ancient nuclear furnace following the laws of physics, and we happen to live close enough to be warmed by it, and close enough, very occasionally, to be singed by it, and we owe every single thing we have ever known to the accident of that closeness. When you understand that, the fear quietly loosens its grip, and something better takes its place. Not the absence of awe, but a deeper kind of it, the kind that holds both things at once, the danger and the gift, and feels not afraid but small in the good way, the way you might feel standing at the edge of the ocean or under a sky full of stars, aware of being a tiny and temporary thing in the presence of something immense and old and beautiful and utterly beyond you. The sun is the most powerful thing you will ever be near. It could, in principle, on some far-off night, reach down and break the world you live in, and it has, far more often and far more reliably, simply kept you alive. Both of these are true. Both have always been true, and tonight, as on every night of your life, it is the kindness that is winning, easily, overwhelmingly, the way it almost always has, but not forever, because the one promise the sun has never made, the one thing its long, steady kindness cannot offer, is permanence. The same furnace that warms you is also, very slowly, burning through its fuel, and a fire that burns must one day change, and dim and end. The truest answer to how the sun could destroy the earth has nothing to do with storms or wires or a single dark night at all. It is far stranger than that, and far more certain, and far, far further away. Part 12. The real ending. The sun has been alive for about 4.5 billion years, and it is, as stars go, comfortably middle-aged. It has fuel enough in its core to go on shining, steadily, for billions of years more. So when we speak of the day it ends the world, we are not speaking of anything that touches you, or your children, or your children's children, across 100 generations and 100 more. We are speaking of a future so distant that the entire history of humanity, every empire and every language and every life that has ever been lived, would not amount to a single tick of that clock. This is the gentlest kind of ending there is, the kind so far away that it asks nothing of you but wonder. And yet it is coming, as certainly as anything in the universe is certain, written into the simple physics of how a star like ours lives and dies. It will not be sudden. Long, long before any dramatic finale, the sun will quietly betray the earth simply by growing brighter. As it fuses its hydrogen into helium across the ages, its core slowly contracts and heats, and the sun gradually, imperceptibly, shines a little more fiercely with each passing era, brightening by something like 1/10 over every billion years. It has been doing this the whole time. The sun that warmed the first life was noticeably dimmer than the one above us now, and it will keep on doing it until one day, perhaps 1 billion years or so from now, it will have grown bright enough that the careful balance that keeps the earth temperate tips over for good. The oceans will begin to warm beyond return, the water will rise into the air and not come back. The seas will simmer and shrink and finally boil away, and the world will become a hot dry stone, sterile under a too bright sun, long before the sun itself does anything spectacular. The end of life on Earth is likely a story not of fire and explosion, but of a slow, quiet, rising warmth 1 billion years from now, on a planet that no one we could recognize will be alive to see. Then, far further on, around 5 billion years from now, the true transformation begins. The sun will finally exhaust the hydrogen in its core. The furnace that has burned so steadily for so long will run out of its simplest fuel, and the careful balance between the crush of gravity and the push of fusion will break. The core will collapse and heat further. Fusion will ignite in a shell around it, and the outer layers of the sun will respond by swelling outward enormously, monstrously, ballooning to many times their present size. The sun will become a red giant, a vast, bloated, cooler, redder star, swollen so large that it will swallow the innermost planets whole. Mercury will go first, and then Venus, engulfed and consumed by the expanding star. And the Earth, our Earth, will stand at the very edge of that fate, so close to the swelling surface that whether it is finally swallowed or merely scorched to a bare cinder just beyond reach is a question the science cannot yet answer with certainty. Either way, the world will be gone, or as good as gone, a blackened rock under a sky filled from edge to edge by a dying star. There will be a strange and violent flourish in the middle of it. When the core grows hot enough, the sun will begin suddenly to fuse its helium, the ash of its old life, into carbon, in a flash of new burning. For a while it will steady itself again on this new fuel, a brief second act. But helium does not last the way hydrogen did. It burns far faster, and soon enough that two will run low, and the sun will have no third act to turn to. A star of our sun's modest size cannot go further. It cannot fuse the carbon. It has reached the end of what it can burn, and so it will let go. Gently as these things go, not in the titanic explosion of a far larger star, but in a slow, beautiful exhalation, the sun will shed its outer layers, drifting them off into space in expanding shells of glowing gas, casting away most of its own substance into the dark. For a span of time, those shells will hang in space lit from within, a vast and delicate structure of coloured gas, the kind of object we see scattered across the galaxy already. The cast-off shrouds of other suns that died before ours was ever born. They are among the loveliest things in the universe, and ours will make one too. A final ornament hanging where the sun used to be, slowly drifting apart and fading over thousands of years,